Greetings, class. In this lesson, we're going to be talking about instrumentation. Instrumentation is sometimes called psychometrics, which is basically the scientific study of measure and instrument development. Hopefully, after we get through this particular lesson, you'll have a better understanding for why it is more advisable and better to use an already established measure rather than trying to develop one of your own. And then also when selecting a measure, you'll have some criteria by which to judge one from another. So instrumentation basically takes your operational definition and brings it to a form of measurement. So taking that vague concept and turning it into something concrete and measurable. When you consider how good a measure is, you consider two components, reliability and validity. Validity is basically the extent to which the measure measures what it says it will, the extent to which the measure measures and accurately performs the function that it is supposed to. There are 5 different kinds of validity that we will talk about in this lesson, although there are other forms of validity that you might encounter. Face validity is the first, and it is the most simple. Basically, when you look at an instrument, on the face of it, does it appear to be valid? Do all the items seem to be related to the concept it is designed for? So let's take a look at a scale, a measure, that has been highly used since the 1960s and considered to be highly valid. The Rosenberg self-esteem scale has 10 items. So if you want, you can pause, take the measure yourself, see how you would score, but read over the items and get a feel for the measure. If we take a look, it's scored on a Likert scale from 1 strongly agree to 4 strongly disagree. And some of the items seem to be in the opposite direction. So some are worded positively and some with the asterisks are worded negatively. This is what we call in the business reverse coding. It's to make sure that the participant is paying attention and not just giving you sort of like all 2s all the way down or all 1s all the way down because they feel they know what the measure is all about and that's how they would score and they just give one uniform response. We want them to read each response and pay attention to it. So sometimes we throw in reverse coded items. Take a look at all the items. Do they all tend to have something to do with self-esteem and not other concepts? On the face of it, does this seem to be a measure about and looking at self-esteem? I would say yes. It's a highly well-established measure, and if you look at all the items, they do have something to do with judgments of self-worth. So face validity is the easiest to establish. Content validity is basically questioning whether all the items deal with just the concept you're interested in and not others. So if we take a look at the self-esteem scale, do all of the items deal with self-esteem and not other constructs, which might be similar or slightly overlapping, but not self-esteem? For instance, depression can be highly related to self-esteem. There are some judgments of self-worth in depression, but we don't want depression items creeping into the self-esteem scale. We want it to be judgments of self-worth and not judgments of depression or whether the person is feeling depressed to sort of be creeping in there and taking over the scale. So do all the questions deal with just that one concept and not other concepts? Predictive validity is the kind of validity that you have to sort of test and do some experimentation to figure out whether the measure has predictive validity. So this might take a little bit of time. Actually, the next 3 would take a little bit of time to establish. So predictive validity is the extent to which the test predicts outcomes that it's supposed to predict. So the GRE is a test that all might be familiar with, or the SAT for college, undergraduate. And these particular tests are supposed to predict aptitude in college or graduate school. Often, the measures come under some scrutiny because they don't do that entirely well. The SAT is a little bit better. The SAT does conform to grades and graduation rates in college a little bit better. The GRE for graduate school is a known underperformer. And part of that, I think, is it tends to predict well, say, your first year in graduate school, and then declines in effectiveness thereafter. So the GRE does not necessarily have, I think, terrific predictive validity. And part of that is that, the first couple of years in, say, a doctoral program, you might be doing a lot of coursework. But after that, you're really kind of left on your own to study for qualifying exams, to write specials papers, and those sorts of work, internships and practicums, and to really work independently, with your mentor, but fairly independently on your dissertation and your own study. And so really the measure maybe can't get at whether someone is a self-motivator and is able to really organize themselves well. And GREs tend to have predictive validity for how people would do with classwork, but not necessarily how successful they might be in the graduate program overall. Concurrent validity is basically whether participants would score in a similar way on a different test of the same trait. So say you're using the audit, which I often use. I use actually the audit C. It's a shortened version of a measure designed to test for probable alcohol dependence. Now there are other things out there. There's the full audit, which is a 10-item measure, and there's also the Michigan Alcohol Screening Questionnaire, which is like a 50-item measure. In my mind, if I could use the audit C, which is 3 items, and gain just as much effectiveness as a measure that's 50 items, why not use the 3-item measure? Well, they had to establish concurrent validity with the measure. That is, they took the measure and they gave it to people along with the Michigan alcohol screening tests and the full audit, and they saw how did the measure, the shortened measure, pair up with these other already established measures. And the answer had been it did fairly well, actually. You could get just about as much out of the 3 questions as you could out of the 50-item measure. So it showed good concurrent validity, that if someone scored with a probable alcohol dependence problem on the shortened audit, they were probably going to get a similar score on the Michigan alcohol screening inventory. That is, if they had dependence on one, they had dependence on the other. The last form of validity is construct validity. And this requires sort of assembling a body of evidence showing that the measure is related to empirical data. That is, that you have a hypothesis of how your construct relates to another one, and you go out and you do a study, and then it shows the nature of the relationship. If the instrument is good, so say if you think self-esteem is separate from depression but should be related to depression, that people with low self-esteem should be more likely to have depression. You go out and you conduct that empirical work, and lo and behold, it shows it and in the direction you think it should. And then you go out and you say, well, self-esteem should be related to grades in school. And you go out and you conduct that experiment. So there's a body of amassed experimentation that shows that the measure works in the direction that it should with other constructs. And this will eventually establish construct validity. The reason why I picked the Rosenberg self-esteem measure is because it's something that's been used since the 60s. It has a lot of construct validity to it. It's been used in a lot of different studies. If self-esteem is there and it is related to something, it generally shows things in the direction that it should. So you can, when picking that measure, if there is self-esteem present and related to something in a particular way, you can have a fair amount of confidence that you would detect it by using that measure. The second set of important things that are going to be related to survey development and selection is reliability. And reliability just means, is that measure consistent and dependable? Does it give you the same outcome each time that you use it? And so there are different forms of reliability showing that the measure consistently measures what it's supposed to. One is inter-rater reliability. So I'm now switching to some highly developed graphics that will be used for this lesson. But inter-rater reliability is basically if you have different observers and they're taking measurements, do they all agree on the particular measurement of a construct? So in this case, I have two observers, and they're going to be observing a baby. That's a baby. And they're going to be looking for, say, social responses in the baby. Now you decide what a social response is, giggles and coos and things like that. And if this observer observes something social, that observer should observe the same thing at the same time. It won't be 100%, right? So that's why we have something called kappa. And kappa is a statistic ranging from 0 to 1, and it shows agreement between researchers. So kappa is a measure of inter-rater reliability. A correlation can be too, as your book points out. But basically, a kappa of 0.80 and above shows good inter-rater reliability. It kind of means they're agreeing 80% of the time that they're seeing the same thing the same way. Test-retest reliability is just that if you give the test today, and then you give the test 3 weeks from now, does the person score in a similar way? So basically, the person takes the test today, and they take the test next week. If the test today shows great aptitude, and all of a sudden 3 weeks later you give it, and that has completely disappeared, you might be suspicious of the test. Really, if a test is good, the person should score consistently in the same way over time. If you have an IQ of 120, it shouldn't drop to 60 if you give the test the next year. And lastly, inter-item reliability. This is when you have a measure and you want to see how well do the items on the measure hang together. You're checking the reliability of the measure to assess a construct. So split half reliability is sort of how it sounds. You take the measure and you administer it to people, and then you basically split the measure, say items 1 through 4 in one group and 5 through 8 in the other, and then you correlate them to each other. If the items correlate highly with each other, it shows good split half reliability. That one half of the measure should correlate fairly well with the other half of the measure if they're all measuring the same thing. If the correlation is very low between the halves of, and again, you don't have to do 1 through 4 and 5 through 8, you can mix them up, but half the items in one pile and half the items in the other pile should correlate with each other to a fairly strong degree to show that the measured items are all interrelated. We tend not to use split half very often though, because there is a better test of reliability, and that is called Cronbach's alpha. Cronbach, because it was Cronbach who discovered it and developed it, he was a statistician. When you're a statistician, you get to name awesome things after yourself when you invent them. But how Cronbach's alpha works is, say you have item 1, it uses a complex mathematical formula to correlate item 1 with 2, with 3, with 4, 5 and 6 and 7 and 8. But then it does the same thing with 2, with 1 and 2 and 3 and 2 and 4 and 2 and 5 and so on and so on. So it correlates every item with every other item and comes up with a coefficient that shows overall how well do those items relate to each other. Cronbach's alpha is often depicted with the little Greek sign for alpha. It also looks like the little fish sign. And it ranges from 0 to 1. So for instance, an alpha of 0.76 is considered okay. Usually alpha of 0.70 and above is what you're aiming for. 0.70 would be okay in a sort of pilot testing mode. 0.80 and above is what is most desired if you're really looking to establish something. And so Cronbach's alpha tells you how well does the overall measure hold together, how well are all the items holding together. So that's it for this particular lesson. So what you guys are going to do is head on over to the discussion. You're going to basically develop a measure. You're going to come up with 5 items for a construct, any construct that you want, and you're going to kind of post and work with each other on developing some aspects of validity for your measure. So that's all, and we will reconvene in another week. So take care.